At the moment, according to NASA's small body database, there are at least 1,449,000 asteroids found. This number, however, could easily skyrocket once the extremely powerful Vera Rubin telescope is activated, which should happen this year in 2025. Still, of over 1 million asteroids currently found, only a tiny number of those was found to have a moon. Less than 500 currently known asteroids are known to have moons. It is somewhat hard to be precise about the actual number. NASA's small body database says that the actual number is 487, but a massive problem with that is that the database also counts dwarf planets such as Pluto and Eris, so excluding most, if not all, of the potential dwarf planets from the list, we are left with a number of 477 actual asteroids that have at least one moon. Now, of those 477 asteroids with moons, only 3 were visited by a spacecraft, and of those 3, really only one could be said to be somewhat well known. The others, not even close. And even further, the moons of asteroids which weren't imaged up close are extremely obscure. So let's first examine the first moon of an asteroid that was visited by a spacecraft. That is Dactyl. It is a tiny moon that is at its longest 1.6 kilometers across. Somewhat unusually, this moon is exceptionally spherical for such a small object. This could be because it is very porous, meaning rather than being one solid chunk of rock, it is possibly composed out of many small chunks of rock gravitationally bound together. This highly porous composition could allow for a somewhat spherical shape even with such small objects. It is also somewhat unusual that the crater imaged on the surface of this tiny moon also has a central peak. Dactyl orbits an asteroid called Ida. Ida is a giant compared to Dactyl. At its longest, it is 60 kilometers across. Dactyl orbits Ida at an incredibly close distance of about 90 kilometers away from the center of Ida. This means that from the surface of this tiny moon, Ida would engulf the view of the sky. Its heavily cratered, regolith-covered surface would be visible in great detail. Regolith is fine-grained soil, which on Ida is produced as a result of so many impacts shattering the rocky surface. Regolith is about 75 meters thick on average throughout Ida, and it sits on top of solid rock. Ida, and with that Dactyl, are close to 3 times further away from the Sun than the Earth is, so they are in the asteroid belt, meaning they orbit between the orbit of Jupiter and Mars. Because of their distance to the Sun and the circular orbit of Ida, both of them have a surface temperature that is consistently below freezing at about minus 70 degrees Celsius. Possibly Dactyl formed as a result of an impact on Ida, which sent rock debris into space, which then got captured into orbit. Both Ida and Dactyl were photographed by the Galileo spacecraft in August of 1993. However, Dactyl was discovered in February of 1994 because the images of the flyby weren't transmitted until that date. The failure of the spacecraft to send the images shortly after the flyby was because one of the antennas on the spacecraft failed, so data transfer was limited to a single antenna, which significantly slowed down the speed of data transfer. Dimorphos is about 177 meters wide, and it is orbiting Didymos, which is about 850 meters wide. The reason that we have such a good image of Dimorphos is because the spacecraft that imaged this moon, called DART, Double Asteroid Redirection Test, actually intentionally crashed into this moon at a speed of about 7 kilometers per second. This happened in September of 2022. This crash then caused the orbital period of Dimorphos to change, so before the impact, it needed 11 hours and 55 minutes to complete an orbit around Didymos, and now after the impact, it needs about 11 hours and 22 minutes. Along with the change of the orbital period, also came the change of the orbital distance of Dimorphos to Didymos, going from 1.2 kilometers before the impact to 1.14 kilometers after the impact, so it got closer to Didymos. What this amazingly detailed image of this tiny moon revealed is that it is very clearly a rubble pile moon. Essentially, instead of being one solid chunk, it consists of many smaller chunks of rock gravitationally bound together. Along with that, there is plenty of dust. That's why this moon also has a density less than that of water. It is very porous. And that is also why shortly after the DART impact happened, a very dusty debris trail was visible coming from Dimorphos. In November of 2023, the spacecraft Lucy approached Salam, which is a moon of an asteroid called Dinkinesh. Dinkinesh has a mean diameter of 790 meters, while the moon Salam has a mean diameter of 220 meters. However, Salam is very elongated, and that is because it is a contact binary. But from this angle, one cannot easily conclude that. However, from a much greater distance, this image was captured of the two objects, and here we can clearly see how the moon Salam is composed out of two blobs sort of glued together. That's how we know that it's a contact binary. As to how Salam got to be there in the first place, the idea is that Dinkinesh was at some point in the past spinning really fast enough such that the material which is at the equator bulged to the point at which it detached from the surface and went into orbit. From that detached material, a single moon formed, which then split into two because they also likely had a fast spin. And then those two moons eventually very gently collided, and then Salam formed out of that. Even today we can see the equatorial ridge present at the equator of Dinkinesh, and around the equatorial ridge there is Salam orbiting. Interestingly, one possible reason as to why Dinkinesh was spinning so fast in the past is due to uneven reflection of sunlight accelerating the spin of the asteroid. Now, the reason that Dinkinesh was able to have its material ejected due to fast spinning is because it is a rubble pile asteroid. Salam orbits the center of Dinkinesh at a distance of only 3 kilometers, which makes sense given that this system is so tiny. However, Salam orbits at an exceptionally slow speed. It needs a bit more than 2 days to complete an orbit around Dinkinesh. This means that its orbital speed is just 0.2 meters a second, meaning much slower than the average walking speed. Dinkinesh and with that Salam are both in the asteroid belt, but closer to the inner parts of it. So those were 3 moons of asteroids which were visited by a spacecraft. Of those, Ida, which has Dactyl, and Dinkinesh, which is Salam, both are located in the asteroid belt, meaning they orbit the Sun at an orbital distance that is between the orbital distance of Mars and Jupiter. Didymos with Dimorphos, however, is not in the asteroid belt. Although it does go in and out of where the belt is located, it can also get extremely close to Earth at a distance that is just several times that of the Moon to Earth. So because of that, it is categorized as being a near-Earth asteroid. Currently, out of about 477 known asteroids with moons, about 91 can be considered to be near Earth. For these asteroids that get very close to Earth, radio telescopes are especially good for getting us high-quality images. In this image, we can see one of the more stunning examples of the level of detail radar telescopes can provide. This is an image of 2015 TB145. This asteroid passed the Earth at a distance of 486,000 kilometers, somewhat similar to the distance that the Moon orbits the Earth, which is 380,000 kilometers. This asteroid is only 650 meters across, and yet the amount of detail provided by the radio telescope is stunning. In a way, radio telescopes can in some examples rival actual spacecraft flybys. So the way that these images of near-Earth asteroids are produced is not through a regular mirror, ground-based telescope. That wouldn't deliver the same quality. These asteroids would just appear as a smudge. Rather, radio-based telescopes send a radio signal onto the asteroid and then pick up the radio signal that is reflected off of the surface of that asteroid with a dish. In total, there are 3 known near-Earth asteroids with 2 moons. All of the other near-Earth asteroids only have 1 known moon. In this image, we can see the asteroid 3122 Florens. It passed the Earth at a distance of 7 million kilometers, and yet we still have pretty incredible images of this object, which only has a diameter of 4 kilometers. It also has 2 moons. The inner one is about 210 meters across. The outer one is larger at 330 meters across. The inner one is somewhat exceptional in that it has one of the shortest orbital periods of a known moon of an asteroid. It completes an orbit in 7 hours. The outer one completes it in 21 hours. And yet still the 7-hour orbit is still slower than the average walking speed. This image was captured by the Arecibo Observatory. It is a radio telescope. The dish of this telescope is static, but it is immense. It has a diameter of 305 meters. So yes, it has a greater diameter than the diameter of the inner moon that it captured in this image of Florence. And it also has a very similar diameter to that of the larger outer moon. Sadly, the Arecibo radio telescope is not operational as it collapsed in December of 2020. In this image, we can see 2001 SN263. This was captured by the Arecibo Observatory. 2001 SN263 is a carbonaceous type of asteroid. They are actually the most common type of asteroid. As the name indicates, these have a lot of carbon in their composition. The previously mentioned asteroid Florence is a stony type of asteroid. As the name suggests, they have a rock-heavy composition, and they are typically more dense because of that. Now, both 2001 SN263 and Florence have 2 moons, and both of those pairs of moons likely formed as a result of the same effect that formed the Salam moon, so through spinning, which released matter which then got captured into orbit. Because of that, the composition of the asteroids themselves also reflects on the composition of their moon, meaning it is very similar. 2001 SN263 is 2 kilometers across. The inner moon is about 800 meters across, and the outer one is about 400 meters across. Although small, not even close to being the smallest moons. That currently goes to 1994 CC, which itself is 600 meters across, while its moons are only about 50 meters across or a bit more, pretty much the size of a somewhat tall residential building. The radio telescope used to capture this image of 1994 CC is the Goldstone Solar System radar. The dish has a diameter of 70 meters, so the radar dish that was used to capture the images of these 2 tiny moons is quite possibly larger than these moons. All 3 of these near-Earth asteroids with 2 moons have an orbital distance to the Sun, which varies by quite a lot. That means that their orbits are very eccentric, that is to say, elongated. Although they do get close to Earth, all of them also go into the territory of the asteroid belt, which is located between the orbit of Mars and Jupiter. However, these 3 asteroids are not really a part of the asteroid belt because they go in and out of the area to such a massive extent. When it comes to the smallest known asteroids with moons, 2004 BL86 is one of those. Its moon has a diameter of 70 meters. The primary object, 2004 BL86, has a diameter of about 300 meters, and its moon orbits it at just 500 meters away. This is one of the smallest known asteroids with a satellite, and it also has the characteristic of going in and out of the asteroid belt. It is also a near-Earth asteroid. However, 2004 FG11 is even smaller. It is another tiny near-Earth asteroid, and it has a diameter of just 150 meters at most. It also has a moon that orbits it at a distance of about 250 meters, and although we don't really know its size, it is certainly smaller than the primary. Sadly, we don't really have good images of this asteroid and its moon. Its really small size, combined with the fact that the closest known approach to Earth was over 7 million kilometers away, is just too much even for the most powerful radio telescopes. However, in the future there is a possibility that it is going to approach the Earth at a much closer distance, so close that it could actually hit the Earth. Although an asteroid and its moon of that size hitting shouldn't be world-ending, but it certainly could cause catastrophic damage on the scale of large cities. Next, let's get a bit further away from Earth. Currently, about 29 asteroids with moons are known which cross the orbit of Mars. Of those, only one has 2 moons. That is 2577 Litva. The primary Litva is not that impressive. It is just a regular asteroid with a diameter of about 4 kilometers. Its inner satellite is about 1.4 kilometers across, and it orbits Litva at a distance of 21 kilometers, and it completes an orbit every 36 hours. This is very typical for moons of asteroids of this size. However, the outer satellite is just a bit smaller at 1.2 kilometers across, but it is also extremely far away from the primary. It orbits Litva at a distance of 378 kilometers, and it completes an orbit every 214 days. That is 7 months. This distance is very much exceptional for a moon of this size orbiting an asteroid that small. Typically, the distances between such small asteroids and their moons are just a few kilometers to tens of kilometers, not hundreds, and because of that, they need much less time to complete an orbit, just a couple of days, not 214 days. Now, such a great orbital distance, coupled with such a great amount of time to complete an orbit, means that this outer moon of Litva is still orbiting Litva way slower than the average walking speed. Next, let's go even further away, to the asteroid belt. The asteroid belt currently has 244 known asteroids with at least one moon. Of those, 9 are known to have at least 2 moons, and only 1 is known with 3 moons. That is 130 Electra. This is the greatest amount of moons found for an asteroid. Electra was discovered in the 19th century, but all 3 of its moons were discovered in the 21st century. The primary, Electra, has a diameter of 200 kilometers. The moons, however, are tiny. The innermost one is 1.6 kilometers across, middle one about 2 kilometers across, and the outermost one is 6 kilometers. Possibly they originated as a result of an impact on Electra, sending debris flying into space, which then got captured into orbit. Despite the great distances these moons have to Electra, they also complete an orbit relatively quickly. They are orbiting at a speed much faster than the average walking speed. So in total there are 477 known asteroids with moons. Of those, 91 are near Earth, 29 are Mars-crossing, 244 are in the asteroid belt, and 113 are beyond the orbit of Jupiter. Of those 113, most of the detected ones are typically a lot larger compared to the asteroids that are closer to us, and for an obvious reason. The more distant an object is, the harder it is to detect. So with that, we are left detecting large asteroids and are more likely to miss the smaller ones. So then let's take a look at a giant asteroid system that is not only just beyond Jupiter, but also beyond Neptune, and that is 47171 Lempo. This asteroid is located at almost the exact same place distance-wise from the Sun as Pluto. So just like Pluto, it has an elongated orbit. And also like Pluto, its closest distance in orbit to the Sun is about 30 astronomical units. 1 astronomical unit is equal to the distance between the Sun and the Earth. So this means that at its closest, Lempo is 30 times more distant from the Sun than the Earth is from the Sun. Now, also like Pluto, Lempo's most distant distance in orbit to the Sun is about 49 astronomical units. This overall distance from the Sun also implies a frigid surface temperature on the objects in the Lempo system. Lempo has a diameter of about 272 kilometers. However, its closest and largest satellite, Hissy, has a diameter of 251 kilometers. They are a binary system because they are so similarly sized. These 2 objects are only about 867 kilometers away from each other, so incredibly close. So close that solar eclipses are incredibly common. During certain points in orbit around the Sun, they are pretty much a daily occurrence, and although they don't take up 100% of the surface area under daylight, during certain points in orbit, they take up most of it. However, during other points in orbit around the Sun, because of the way their orbits are tilted relative to the Sun, solar eclipses just don't occur. Now, from the surface of each object, the other one would appear many times larger in the sky than the Moon does from Earth. In fact, they would take up a similar amount of space in the sky to the amount that is taken up by solar systems, non-terrestrial planets, from the surface of their major moons. So from Lempo and Hissy, the other object would engulf the view of the sky. However, that would only be the case from one side of them. That is to say, these objects are tidally locked, meaning the same side of them is always facing the other object. So from the surface of Lempo and Hissy, the other object would appear to be static in the sky. Because these two objects have such a similar size, their masses are also very similar. Because of that, the center of mass that both of these objects have is outside of themselves, so they are orbiting a point in space that is outside of themselves. However, there is another object in this system that also significantly influences the center of mass, and that is Pacha. That's right, there is a third large object in this system. Although smaller than Lempo and Hissy, Pacha is still very large for an asteroid-shaped object. It has a diameter of about 132 kilometers. It orbits the center of mass at a distance of 7,600 kilometers. So because Lempo and Hissy are so close to each other, they are both also about 7,600 kilometers away from Pacha. Because Pacha is significantly smaller than Lempo and Hissy, in a sense it could be considered to be just a moon of these two. Pacha needs about 50 days to complete an orbit around the center of mass, quite a bit more than Hissy and Lempo, which need just 1.9 days, which makes sense given their much closer distance. As to what Lempo and other objects in the system are composed out of, it's not entirely known, but what is known is that Lempo has an extremely low density. Its density is estimated to be only about 0.54 grams per centimeters cubic. That is way less than the density of water, which is 1 gram per centimeters cubic. For an object of this size, this density is a bit stunning. So its density implies that it is a giant rubble pile object that is extremely porous. The density of Hissy, on the other hand, is estimated to be 0.9 grams per centimeters cubic, much greater. It is so much greater, in fact, that despite Hissy being slightly smaller than Lempo, it is also slightly more massive than Lempo. So, in a way, Lempo is a satellite of Hissy. Pacha is also very intriguing with regards to its estimated density. Although the numbers are far from being precise, this study claims that it is at least below 0.46 grams per centimeters cubic, so possibly it is even quite a bit lower, which is kind of amazing for such a large object. So it is the most porous object in the Lempo system. The composition of these three objects in the Lempo system is not known, but for Lempo specifically there are some indications at least. Some visible and infrared observations point towards a composition of water ice, silicates, and a massive portion of complex organics. So a large part of Lempo could be made out of complex carbon-based molecules. As to how any three of these objects formed and then got together to form a system with such bizarre orbital characteristics, that isn't known. Lempo was discovered in October of 1999, but during that time it appeared that Lempo was just a single body. 2 years later, in December of 2001, Pacha was discovered. However, it wasn't until 2006 that someone got the idea that Lempo could actually be just two bodies that orbit each other so closely that they appear to be just one. Then, a year later, in 2007, it was noted that Lempo appeared to be unusually elongated, and ultimately the Hubble Space Telescope images of the system in 2009 allowed for the conclusion that Lempo is actually two different bodies orbiting each other at a very close distance. Now let's take a look at the most distant known asteroid that has a satellite. That is currently Ceto. This asteroid is in 2025 about 44 astronomical units away from the Sun. Although currently further away from the Sun than Uranus and Neptune at its closest points in orbit, this asteroid gets closer to the Sun than Neptune and even Uranus. Its closest distance to the Sun is about 17 astronomical units. However, Ceto has an extremely eccentric, elongated orbit, one of the most eccentric ones in the solar system, and because of that it gets to get as far away from the Sun as 187 astronomical units, so 187 times further away from the Sun than the Earth. Given this immense distance, it is understandable that Ceto needs 1,047 years to complete an orbit around the Sun. Ceto was discovered in March of 2003, and shortly after that discovery, the images from the telescopes in the past were examined, and it was found that Ceto was actually imaged at least as far back as 1987. Those old images then allowed for it to be quickly determined as to what the orbit of Ceto looks like. If those old images weren't there, we would need to wait quite a bit more time to get a determination of what the orbit is like for Ceto. And that is because it takes such an insanely long amount of time for it to complete an orbit. So then, what about Ceto's moon? Well, similar to Lempo, at first, that is in 2003, it wasn't known that Ceto is actually two objects. Its moon was first identified later in April of 2006 from the images obtained from the Hubble Space Telescope. The resolution obtained clearly allowed for its satellite, Phorcys, to be identified. It orbits Ceto at a distance of just 1,800 kilometers. However, there is somewhat of a problem with calling Phorcys a moon, and that is because of its size. The estimates between two different studies vary, but the latest one claims that Ceto is about 220 kilometers across, and Phorcys about 170 kilometers. So very similarly sized, enough that their mass is similar enough such that they orbit a point outside of themselves, and they complete an orbit around that point every 9.5 days. So calling Ceto a binary system is appropriate, although they are not so similarly sized such that calling Phorcys a moon is inappropriate. Phorcys is, after all, a satellite of Ceto. The older study on Ceto and Phorcys claimed that their density is around 1.3 grams per centimeters cubic, so a non-porous half-rock, half-water ice composition. The newer one claims that they have a much lower density of just 0.64 grams per centimeters cubic, meaning that they are porous rubble pile objects. The newer study got the much lower density because the mass estimate stayed for both objects, but they estimated that Ceto and Phorcys have a bigger size compared to the older study. Now, it might be the case that Ceto having Phorcys as a moon is unsatisfactory, because after all they are pretty similarly sized. But if that's the case, then there really aren't any known truly impressively distant asteroids with moons. And that's simply because these extremely distant asteroids that are at distances beyond Neptune are also pretty hard to detect on their own. So naturally, the asteroids that are that far away that do get detected are also pretty large. So the ones found aren't in the range of a few kilometers, which is what a small asteroid is. Rather, the asteroids detected at those distances are typically around 100 kilometers across or more. Along with that, because small asteroids at those distances are hard to detect, small moons of asteroids are also hard to detect. So that massively narrows down what can be detected, and what we are left detecting because of that are moons of asteroids that are similarly sized to the asteroids that they are orbiting. So that makes them a binary system. The satellites of asteroids which were found beyond Neptune are typically similarly sized to Phorcys, and the primary in the system is somewhat similarly sized to Ceto. One object, however, that somewhat sticks out in that regard is 2000 YW134. The primary is about 230 kilometers across, while the satellite, the moon, is about 75 kilometers across. So they are definitely very different in size. However, the satellite is still pretty large in relation to the primary. Finally, let's take a look at the opposite. Instead of looking at moons of asteroids that are extremely far away from the Sun, let's take a look at the closest asteroid to the Sun that has a moon. That title currently goes to Moshup, and it does so by far. Moshup gets as far away from the Sun as the Earth, and with that it also gets extremely close to Earth too. So close that it is classified as a potentially hazardous asteroid. In 2036, it is going to get 2.3 million kilometers away from Earth, just 5 times the distance of the Moon to Earth. Now, although Moshup gets as far away from the Sun as the Earth, it also has an extremely eccentric, elongated orbit. So at its closest, it is 0.2 astronomical units away from the Sun, a lot closer to the Sun than Mercury. So Moshup and its moon get extremely hot on the surface during those points in orbit, at least on their day side. Their surfaces probably achieve a temperature of several hundred Celsius. Moshup has a diameter of 1.5 kilometers, while its moon, called Squannit, has a diameter of just 360 meters. This tiny moon is about 2.6 kilometers away from Moshup, and it completes an orbit every 16 hours. so its orbital speed is very slow. Moshup is very likely a rock-heavy rubble pile moon. Its density is 1.9 grams per centimeters cubic, quite a bit less than that of actual rock. That is also why it gets to have a very protruding equatorial ridge. Potentially out of the material that escaped that ridge is how Squannit formed. That's why Squannit is going around the equatorial ridge. Moshup was discovered in May of 1999. Its moon Squannit was discovered in May of 2001 by the Goldstone Observatory, which, as mentioned, uses a radio telescope. Then in May of 2019, images of Moshup and Squannit were taken by the Arecibo Observatory, another radio telescope. However, also in May of 2019, somewhat uniquely, a mirror telescope was used to observe Moshup and Squannit. Specifically, this image was captured by the Very Large Telescope. And although the surface details are very blurry, somewhat surprisingly, a ridge present on Moshup was captured. It is almost certain that the current number of 477 asteroids with moons is going to change, and potentially very soon. As mentioned in the beginning, the extremely powerful Vera Rubin telescope should become active this year in 2025, and with that many more asteroids are going to be found. Millions. Almost certainly, quite a few of those are going to have moons as well. Maybe that could also lead us to discover the first known asteroid system with 4 moons. With regards to the future spacecraft missions to asteroids with moons, that is also very promising. The Lucy spacecraft, which did a flyby of Dinkinesh and Salam in 2023, is also going to do a flyby of quite a few other asteroids. Of those, at least 3 have a moon, so we are going to get to see them up close. In August of 2027, Lucy should get to visit Eurybates, an asteroid 64 kilometers across. It has a small moon which has a diameter of 1 kilometer. For such a tiny moon, it is also very far away from Eurybates, at about 2,350 kilometers away. Eurybates is not in the asteroid belt. It is further away from the Sun. It is a Jupiter Trojan, meaning it shares the orbit of Jupiter around the Sun. Then just a month later, in September of 2027, Lucy should get to visit Polymele, another Jupiter Trojan. It has a diameter of 21 kilometers, and it has a moon with a diameter of about 5 kilometers. The last planned flyby for the Lucy spacecraft should happen in March of 2033. It is planned for Lucy to visit a Jupiter Trojan called Patroclus. It has a diameter of 113 kilometers, and it is a dark, carbon-rich asteroid which has a density lower than that of water, so it is a rubble pile object. Patroclus has a very similarly sized satellite called Menishas. It has a diameter of 104 kilometers, so they are a binary Jupiter Trojan. They are about 680 kilometers away from each other, and they complete an orbit around the center of mass every 4.3 days. Now, several years before this final flyby, in November of 2028, it is planned for Lucy to visit a Jupiter Trojan called Aras, which is 51 kilometers across. This object has some hints that it has a moon, and the Lucy flyby should help confirm or disprove the existence of this potential moon. Moons of asteroids are a very obscure topic, and yet despite that, somewhat unusually, the future with regards to the exploration of these objects is very bright. We are going to continue getting a bigger and bigger list of these objects as powerful telescopes become active, and on top of that, spacecraft flybys of these objects is planned. Considering just how obscure these objects are, and knowing that resources are finite, at the moment it is hard to ask for something more.